This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
Good evening and welcome. I'm Nigella Hilgarth. I'm the Executive Director of the Birch Aquarium and Scripps at UC San Diego. Delighted to have you here this evening for the latest Jeffrey B. Graham lecture series, Perspectives on Ocean Science. It's always a privilege to introduce Dr. Charlie Kennel. He is an incredibly distinguished man, and so if I really told you more than a snippet about him, we'd be here all night and there'd be no time for his talk. He was Associate Administrator at NASA for the mission to Planet Earth, the world's largest Earth science program. And he was then the UCLA Executive Vice Chancellor, and after that he became the 9th Director here at Scripps Institution of Oceanography here at UC San Diego. And he has stayed all that time while he was director, and since then he has still been very, very involved in space. He, in fact, is a member of the NASA Advisory Council and has been since 1998 with 1 or 2 years off. So that's an incredible long history and long time to be part of the NASA Advisory Council. And he is also the chair of the National Academy's Space Studies Board. So there's really nobody better to talk about the future of human space exploration as one of the most distinguished people who's associated with UC San Diego and Scripps Institution of Oceanography. I also want to say, because he used to be my boss, that he's also one of the most marvelous human beings it's been my privilege to know. So Charlie, I would like now to ask you to come and talk to us tonight. Thank you.
So good evening. Thank you, Nigella, for a lovely and brief introduction. It's a pleasure to see so many old friends and some new ones. And I suppose you're looking up at this slide here and asking, what in the world is a talk on human space exploration? What does that have to do with perspectives on ocean science? And I'm mindful of Roger Revell's statement that oceanography is what we do at Scripps. And this is one of the things I did for quite a number of years here. So when I came on board as chairman of the National Academy's Space Studies Board in 2009, the Space Studies Board had just spent an entire year celebrating the 50th anniversary of NASA. And so I came in just after that wonderful celebration and wondered exactly what was in store. So when I came on board, I was very much aware that the age of 50, 45, or 50 is an important age in the lives of us all. You've lived long enough to evaluate the life you have lived, but there's still time to make changes. So one asks oneself, what did I achieve? What should I do with the rest of my life? What should I throw away? What should I keep? Can I still do what I did in my youth, only better? So now I found NASA in the same mood. And since that time, they really have been preoccupied with a complete reexamination of their future as a mature enterprise. And I've been lucky enough to participate in helping think through some of the issues and hopefully finding a way towards an enduring future for human spaceflight. So starting off with the first question, what did we achieve? This is a picture that NASA put together, a little mosaic that shows the things it was most proud of in its past. And we should remember that NASA, before there was spaceflight, was one of the prime developers of modern aeronautics. So there's an early airplane. You can see the Saturn rocket, the Mercury 7, the world's largest vacuum tank, the SR-71 Blackbird, footprints on the moon, a storm on Jupiter, the Earth observed from orbit from the first time, the shuttle, the Horsehead Nebula taken from the Hubble, rover tracks on the moon, the space station, Saturn's Ringsmore space station, a hurricane from above, and so forth. So that's a good summary of what NASA did. But more importantly for the country, through their leadership, they built a global space economy. And that space economy is so embedded now in our lives that we hardly ever notice it. But there's things like Google Earth and GPS and most of our telecommunications. The weather forecast we occasionally notice even if we don't trust it. And of course, there's an important element of national defense. So NASA's leadership in the civil space enterprise has had far-reaching implications in the hands of others in U.S. industry and global industry. But the high point for human exploration was 44 years ago. And we should remember that after this enormous success that many of us who are old enough remember, the lunar missions were discontinued after only 5 years. And the question before NASA at that time, and still today, is how can we top that? What can we do that's more exciting? This was the question that beset NASA planners well ahead of the first successful landing on the moon. And what I've shown here is a plot of the NASA budget history as a percentage of the total federal budget. And you will see that it reached a peak about 1964 and then suddenly dropped 5 years before our astronauts landed on the moon. In fact, the funding for NASA as an enterprise dropped precipitously as soon as the administration understood that the Soviets were not going to compete effectively on the moon landing. So you can see then, and 5 years later, by 1974, that was the last human mission to the moon. And we haven't had one since. And you can see that the level of the budget as a percentage of the federal budget was set pretty much at that time, with a small increase, and now, for the last 20 years, a slow but steady decline. So what was the NASA's greatest interest at that time? It was to simply assure human access to space. They wanted to make sure that there would be routine human access to low Earth orbit, and thus continue the space program and avoid any further precipitous declines in funding or national interest. And the answer for doing this was the space shuttle. The idea was at that time, maybe 50 years ahead of its time, that they would build a reusable, heavy lift, 70 metric tons, to low Earth orbit. And this was going to carry both huge observatories and at the same time small onboard experiments that experimentalists could place on board, fly in space, and get the answer back in a week or two. And when STS-1 Columbia was first launched in April '81, NASA believed that there would be a shuttle launch a week. But by the time we arrived in July 2011, the last flight of Atlantis, as you can see there, we were having 4 to 6 flights per year, about $500 million each. And so it did provide access to space, but certainly not routine. Nothing was routine about a shuttle flight. Now, what were some of the things that shuttle did that were, I would argue, provide the greatest argument for the value of that part of our space program? Probably the most striking and important experiment was the Hubble Space Telescope. Here you see an image of it. It is the only space experiment, the only orbiting instrument designed for human repair. it relied on routine access to space so that astronauts could get to the Hubble telescope and refit it with new instruments. And so each repair mission created a virtually new telescope with new electronics and new focal plane imagery. And those repair missions were worth $500 million each. The shuttle also had a big impact on the field that I oversaw. And here is my favorite mission from that period of time. The Shuttle Imaging Radar, SIRC, carried into orbit the largest and most powerful radar probably ever flown in space, and it made extremely detailed maps in radar of the surface of the Earth. It also saw beneath the surface of the Earth in dry areas and has made a large contribution because it detected underground archaeological remains. And it did a lot of other things. Its follow-on, when we added a second antenna, created a digital elevation map of the Earth at high resolution that has still not been superseded. And the biggest and the most important thing, probably, that the shuttle did was create the International Space Station through a series of more than 70 shuttle flights to orbit to bring heavy equipment and all of these modules, an international module, to space station. And most people who think, is NASA doing anything in space? The answer is that the station has been permanently crewed by humans now for the last 13 years, a continuous human presence in space. The other part about it was the space station, as it was designed, was a completely international mission. And here through 2010, I'm sure there are more now, there were 59 countries that had access to the space station and sent astronauts and experiments into orbit. And so those are some of the great things that the shuttle did. But we also learned through this experience that great things are never routine. You can build a system, the engineers among us will understand conflicts and requirements. You can build a system that can do a few great things, or one that does a lot of little things, but it really is hard to try to do both. And that's what NASA tried to do with the shuttle. And it did do great things. Hubble, ISS, International Space Station, CRC, a few others. And probably more importantly, it taught us far more than we ever knew before about how human beings live and function in space. A store of knowledge about human physiology and the reaction to space conditions that is, in fact, the basis of knowledge for future human exploration. But as we saw from the infrequent launch frequency that we were able to achieve, that it gets very expensive when you use a system built for great things to do little things, which is maybe why the experimental part of the shuttle program and life and microgravity science never prospered on the space shuttle. At the same time, the shuttles were, in fact, being launched 4 to 6 times a year, and that meant that there were 4 to 6 occasions in which the public interested in space could hear about what NASA was doing on the general media. And so it was that just after the last shuttle landed, The Economist, probably our most influential news magazine at the global level, declared that the end of the shuttle was the end of the space age. Now, I don't think there are many people in NASA that believed that, and I didn't. But I certainly didn't know what was going to come next. What should we do for an encore? We had the same question back in the 1970s. How do you top astronauts landing on the moon? What is the encore for the shuttle? Well, as early as 1998, the NASA Advisory Council was already warning that the low shuttle flight rate and the high cost per flight threatened to make the human access to space unsustainable, and shuttle replacement was becoming urgent. So it was at that time that the NASA Advisory Council commissioned a series of different studies and quiet explorations to try to ask the question, is there an alternative to the space shuttle? Was there any new technology, single stage to space, any new technology that could make access to space cheaper? That would revolutionize the space enterprise. And the answer was no. Was the military interested in a new human vehicle? There, the quiet answer was no. Were there potential industrial partners willing to share the risk? The answer was not at that time. So after several years of hearing from these studies, we reluctantly concurred in NASA's view that the best replacement for the shuttle was a shuttle upgrade. Replace the fuel tanks, put in somewhat more modern electronics where it was possible, and try to make the whole system safer based on our experience. Now, this kicked the can down the road for another 10 years. We thought we had bought 10 more years of life to the human spaceflight enterprise without having to worry about what came next. But actually, we didn't have that much time. The Columbia tragedy in 2003 brought the shuttle retirement to a head. It was an intimation of mortality, and it taught us and the engineers and all of those who oversaw the flights that no human space mission is routine, not routine. So what was the first approach to the next stage in the human exploration program? And this was a vision for space exploration that was announced by President Bush in 2004. It was very unusual. The foreign space agencies were extremely jealous of NASA because they could rarely get, at that time, their heads of state to make a statement in favor of space. And here Bush was proposing an entire new program. The basic program that he proposed was, first, let's not replace the Columbia, go with the 3 remaining shuttles, but complete the space station, keep our obligations to the international partners, then retire the shuttle, and build new systems to go first to the moon, and then eventually go to Mars as a distant objective. And that, in many ways, does remain the prime distant objective in many people's minds. But that program almost immediately ran into trouble. And there were 2 parts to it. There was a part with the program rationale, and there was a part with the program funding. And they were actually, in my mind, they were related. Everybody asked, haven't we already been there and done that? Why are we going to the moon again? Can somebody give a good argument for going to the moon? Or what's going to be different? Well, what's different was the vision that you see there, costing more than $100 billion of settlements on the surface of the moon. And these astronauts would be thoroughly irradiated after just a few months on the moon. On the other hand, if you go to the moon, are you developing the technology and just using that objective as a stepping stone to Mars? Or is the moon interesting in its own right? And the answer is, at the scientific level, yes. But are we going there just for lunar science? And then I think most significantly, we made this announcement without carrying our international partners along. So why are we going to the moon alone when we've been busy constructing the space station with 14 countries as partners? And then, because of this inclarity of rationale of the program, in part, we can ask the questions at the bottom. Why didn't that program, so-called Constellation program, why didn't this attract enough funding, despite the fact that the president announced it? And when it didn't attract enough funding, and it was about $3 billion a year short, when it didn't, why did we keep going and try to do it? And this was the situation that I faced when I became chairman of the Space Studies Board and President Obama became president of the United States. And I don't want to compare them, but it happened at the same time. And so, once again, the question, once again, is one more time, where do we go from here? So this was the subject of the president's question, and he formed a commission in which I served that met for a better part of a year in 2009. This is the picture at the Marshall Space Flight Center, and you can see me on the very right end. First there's Sally Ride on the far end, and then me. And Sally and I wrote a good part of the section that I will describe in a moment, and I think we all miss her very much. So what did the Augustine Commission do, aside from a lot of technical studies that were just sanity checks on four basic policy initiatives? The first was to extend the International Space Station to at least 2020. The increase in costs on the Constellation program had forced NASA to declare that it was going to retire the space station in 2015. It had only been fully crewed with 6 astronauts since 2010. So after 20 years of construction and 70 shuttle flights, you were going to have 5 full years of operation, and then you were going to close it down so you could sweep up the money and put it into this Constellation program that was chronically bleeding and couldn't probably be funded. So that was our first conclusion, that you have to continue the International Space Station. And the reason was, aside from the technical accomplishment and aside from the science that could be done, the most important asset in space that we had was the international partnership that built it. And it already had a very important aspect to it because there were program failures along the way, and the participation of multiple countries in the support of the space station, especially Russia, enabled the space station to continue. So the international partnership was not only a great diplomatic achievement on NASA's part, but it was essential to providing continuity to the space station program. There was a psychological aspect to all of this that we encountered, and that was that if we do that, we have to admit our dependence on others in the operation of the space station. In fact, we already had been dependent on others because after the Columbia accident, the US launch capability shut down for 2 years, and the Russians saved our bacon. But the other part of the dependence, and this is what you'll see later, is that we were now going to depend in part on American entrepreneurial companies. And this is probably the most significant change in philosophy that NASA has had since the moon or lunar launch. So we were going to have commercial launch the International Space Station. And what did we mean by that? We were going to separate the great and the routine. That it was now time, and the technologies were now mature enough, that independent risk-taking companies like space exploration or orbital could take over much of the burden of routine access to low Earth orbit, including eventually the launch of human beings to the space station. And as you know, there have been, SpaceX has had 2 or 3 launches, supply launches to the space station already. So NASA's job at this point was to step back from the development of these stations and their engineering, but to promise that if they met certain basic safety and other qualifications, that NASA would in fact be an anchor tenant and buy the launches to Earth orbit basically by the yard. And I will talk about the implications of this later, but this was a dramatic change in philosophy that most people didn't expect would occur as easily as it did. So the next part that Augustine discussed, was to prepare to expand the human presence throughout the solar system, to leap off from Earth orbit and go deeper into space, possibly one day to Mars. But we also understood that there were lots of other interesting things that we could do beyond low Earth orbit. There's plenty to explore, asteroids, as you'll see, the moons of Mars. You could go to a lot of places without carrying the expensive landing equipment that you see in the center and take astronauts on voyages that we hadn't thought of before. So in order to do that preparation, we built a heavy lift launch vehicle that's larger than the shuttle. And here's the one that's called heavy lift is an artist's representation. But the basic idea is that we should start technology development now and choose the destinations. Which one of these different destinations on the flexible path would you go to? And this is the sense now in which, since it will take at least 10 years, or from then 10 years, to build this heavy lift launch vehicle, there'd be a 10-year period in which we had to admit our dependence on non-NASA assets to reach the station and to carry out most of the functions that we had been doing. So that would be the commercials and our foreign partners. So, in the path to the future, therefore, to the future of human exploration starts, let me repeat, it starts with the space station. Now, what did we have to do? The space station changed from being moribund and about to be retired to an object that was a stepping off point for at least the human experience to deeper space. And so suddenly it became important for NASA to not treat it as a sick patient, but in fact to build it up and to strengthen its role for the United States as well as the global community. So one of the first things that had to happen when the Constellation program was under budgeted, NASA had to cannibalize a lot of programs, including their small experiment research program, which failed on the shuttle because there wasn't enough space in the interior of the shuttle, but had a chance for being productive if you put these experiments on the space station. But we cannibalized the program, but the Europeans, not faced with the budget problems of actually building the station, were able to develop a program systematically and slowly. But now, for the first time, success on the space station depends on how well the country, how NASA is using it. The Congress declared the space station to be a national laboratory, like Los Alamos and Livermore. At our recommendation, they have developed a separate organization to manage the research to operations interface, a group that can translate requests from people who've never flown in space to the bulky engineers at Johnson Space Flight Center. And we felt that station had to have stable funding. Now, the important thing was we also felt that it would be unwise as a policy to declare that the station was also going to end in 2020. We'd only extended it by 5 years, but we believed that the extension should be indefinite and should be voted upon by the partners every 5 years or so, depending on the value that the station is returning to our and their programs. So, and one of the things that was tremendously important was it was clear to us that with things going down in 2015, there was no incentive for new scientists and new ideas to get involved with space station research. They could just barely get involved, and NASA wasn't terribly interested in it, so it wasn't a good thing. But in fact, the promise that the station will be up there for a significant length of time has the potential to attract new scientific experiments on board from people that never thought that space would be a place where they could do their experiments. And the prime example of that is an experiment, the alpha magnetic spectrometer, a big high-energy physics project that was led by the MIT's Nobel laureate Sam Ting. And Sam got a whole international collaboration of countries around the world to put up about 80% of the costs of this $2 billion project. NASA was the minority funder. But the station attracted a major facility, and they believed in their advertising that NASA wouldn't dare, as it didn't, close down the station so that the alpha magnetic spectrometer could last for 10 to 18 years. So this is an example then of where access to space, to the radiation environments of space in this case, or to the low gravity environment of space, really does turn the space station into a kind of national laboratory. In Europe, for example, the high-energy physics, it's very expensive to do high-energy physics. But if you want high-energy particles, there's only one place in the world you can go to get them, and that's at CERN. And you have to put up with the bureaucratic and complexities of a vast organization. Well, if you want access to low gravity, the only place you can do it is a space station. And so it will attract, in my view, users, provided they know that it will be there long enough for them to accomplish their goals, and provided they believe there is an organization that can deal with the complexities of NASA space engineering. So I began to think that perhaps eventually in the fullness of time, the space station program, which is fully international, might develop more or less the way the research programs have developed in Antarctica. And 2012 happened to be the 100th anniversary of Robert Falcon Scott's ill-fated expedition to South Pole. There you see the disconsolate 4 members of his team standing before the tent and flag that Amundsen put up a month before. So in 1912, it was dangerous exploration by a few intrepid human beings. But after the Second World War, the US Navy decided to provide routine access to the Antarctic continent. If you had an experiment, they'd take you there. They'd house you. And now the Antarctic is a very active research site for high-energy physics, astrophysics, climate science in particular. And so it's possible that just providing the opportunity to go to this exotic place may, in fact, make the space station grow in value as it grows in age, unlike a lot of other things. But one of the things that Sally and I did was also ask ourselves, well, before you could decide whether to extend the station, you should ask how ISS, how should it end its days? What should you do with it up there? Should you deorbit it, send it into the Pacific Ocean, or should you mothball it, put it up into higher orbit and close it down, and just let it be there? And we realized another aspect that had not been thought about at that time was that the decision to deorbit was as complex as any large new program. And in fact, a new vehicle would be required to control the deorbit, and it was going to be a multi-billion-dollar experiment any way you looked at it. And it was going to be billions of dollars spent on something you didn't want to do. And then the ISS, the international partners had to agree on this. So they'd have to complete all their ongoing programs. Could we arrange for equipment retrieval and the apportionment of costs? There were unknown international repercussions of this decision. One of them was that we didn't know if it broke up on the entry. We didn't know what the risk was of adding to the problem of space debris. Objects orbiting, small objects orbiting in space. Today, this problem is not very salient, but in 20 years' time, it's going to be a terrible crisis because these objects all collide with one another, and eventually they're going to threaten most of the things that we put up in low Earth orbit. We already saw when the Chinese blew up a satellite at in low Earth orbit, they made a major problem for space debris. And the other problem was that even if the debris didn't go into space, how many nations are going to be worried about it falling on their territory? So none of these things had been thought about. So then it was also quite clear that it was cheaper and safer to boost it than it was to deorbit it. But at the same time, if there are not human beings on the system, there's probably a factor 5 increase in system risk. And the maintenance costs would still remain substantial. So you'd be paying a fair amount of money to keep something up there doing nothing, when you probably still would like to be doing something. So when I was at the Scott Polar Institute at that 100th anniversary, they had, not at the anniversary, but they had a exhibition on space. And during that time, we had a discussion. And there we said, well, the indefinite lifetime does encourage creative use. That, I think, point I've already made. But is it now time to think about declaring the International Space Station a UNESCO World Heritage Site? Certainly merited. And by doing it, it's worth it, it's an honor, probably deserves it as one of the greatest engineering achievements comparable to the Eiffel Tower and other things for its time. But if we did that, it would probably encourage people it would bring in a larger group of stakeholders into the decision of whether the space station should stay up there or come down, or what we should do with it. It's an international asset that belongs to actually global society. So moving on then, question now is, same question, where does the path from ISS to the future lead? And this was Augustine's unanswered question. Recently, the Obama administration has come up with an interesting idea on the flexible path. And the idea is to, well, I'll explain it on the next slide, a visit to a small planetesimal. You'll use a commercial launch vehicle to launch this little object in the upper left, which is a special spacecraft that is powered by solar electric propulsion. It's going to use the electricity generated on board the spacecraft and shoot a beam. It's an ion rocket, if those of you who like science fiction. So in the lower left, you see this spacecraft approaching a small asteroid about 20 feet across. And there's this accordion-like thing that contains a balloon, and it will envelop that little asteroid. And then on the upper right there, it's using its ion drive again to pull the asteroid back to not low Earth orbit. People might get nervous if they thought NASA might make a mistake putting in a 7-meter, 20-foot rock into orbit. What happens if we make a mistake? So they're going to put it in a stable point. There's a few stable points in the Earth-Moon system where, with just a little bit of guidance, it would remain relatively stationary. And then at that point, once you've accomplished all of that, you'll send the astronauts up on our commercial launchers. They will then do their resource exploration and study this in great detail and bring pieces of it and drill holes in it and do all the things that scientists do and bring it all back to Earth. An important thing about this is very different than a single leap to the moon or the idea of a 300-day mission to Mars. This deploys, if you can actually pull it off, it deploys a whole range of technologies that involve how human beings operate in space. It extends the range of operations that we can carry out. The other aspect of it is that it makes the presumption that there will be a vibrant low Earth space economy, such that access to space will be cheaper, and you will be probably encouraging private enterprise to visit this asteroid. So this then brings up an interesting question about space law. If you land first on an asteroid, do you own it? Does it become part of the United States? So there's some interesting policy questions to be thought through. I think the first thing is that what you've seen here is some nice pictures and a concept that I personally think is quite exciting. It remains to be seen whether the engineering works out. It's plausible and has had some sanity checks. And even more important, it remains to be seen whether it will be funded by the Congress. But this is a new style of NASA thinking that has taken place quietly during this period of time in which our ability to launch our own rockets into space has stood down, and we are trying to build a heavy lift rocket. Now we should go back, having reviewed the difficulties with the first Constellation program, that the concepts that drove the program were its ultimate weakness. I now have to tell you something about what I think is the most important study that our National Academy will carry out. And Academy was asked to do a study on what the enduring goals for space exploration would be. And we've recruited two people, a very competent astrophysicist, planetary scientist, Jonathan Lunine, and Mitch Daniels, the former governor of Indiana and now the president of Purdue, and asked them to co-chair this. The Senate asked us, had the following approach, and what they said was, why are NASA's science programs so successful? Why do they advance so steadily? And their answer was that for each of the science programs, there was a discipline that developed fundamental questions and kept asking those questions until they got answers, and then they moved on. And their question for the future was, can we develop a similar set of questions that might provide people enduring reasons to continue to go into space? The story I've told you has shown you great fluctuations in public and government support. So they were going to ask to identify the kinds of questions that might, in fact, motivate a long-term commitment to space. And I don't know, they're in the midst of their studies. I do not know what they will come up with, but it's a very broad committee consisting mostly of non-space scientists, people who think about international policy and human relations and economics. But it has two technical subcommittees, one consisting of people, space engineers, to keep them all sane if they should go off the reservation with a fantasy. And the other one, just as important, was to find out what is motivating people's support today for the space program. And so we have, the Academy has provided us through its social science division a committee that is looking at scientific opinion sampling on the reason for space. So they will come up with their report. But I think that's only the beginning. That's only the beginning. The broader community of space, that is to say, all of those people that are concerned by it, their stakeholders, those who think about it in general, beyond NASA and beyond the kinds of experts that the Academy can hire, have to also do some rethinking. And of course, down the middle column here, you'll see the people important to NASA who have to do some rethinking, whether it's the White House, the Congress, the big space industries, and our international partners. But on the left, you see the kinds of people that form notions and ideas about space. The National Geographic, the Planetary Society, great authors, whether it was Jules Verne or UCSD's own Kim Stanley Robinson, Space Art, the newspapers, the people who think and form opinions about complex topics. And on the right, you'll see the larger global community International Space University, space buffs that love to go to launches, and of course, a global community of universities. And I do not think that one Academy committee is going to provide us with enduring questions, but they're going to provoke a broader level of thinking than we've seen in a very long time. And if that comes together, then we may be able to cope with an enduring commitment to space, human exploration. The answer at the present time, given the global environmental crisis and lots of other things, is never obvious that we should be doing this. But there are questions that you do have to ask. For example, technologically, is the human spaceflight enterprise sustainable? Can we actually keep it going at the engineering level? And this is the subject of a 100-year study of a 100-year space mission that the Defense Advanced Research Project Agency and NASA are taking together. Do we have the technology to keep a mission going for 100 years? Well, this isn't the first time that NASA has had an intergenerational mission. And in fact, the Voyager mission was the first one. It was designed in 1969 by a science advisory group. I was the youngest member on that group. So the first launch, there were 2 spacecraft. The first launches were in 1977. We went by Jupiter, and then we went by Saturn, Uranus, and Neptune in 1990. And the mission continues. The 2 of them are on their way out of the solar system. And there's a big argument as to whether they, in fact, have reached the plasma boundary of the solar system or not. Have we sent a human object into the interstellar medium? That's not 100% clear. Recently, JPL, that manages this project, has declared that they think eventually the nuclear power systems of the spacecraft will run out perhaps in 2025. So here is a mission that was kept going for more than 2 generations simply because people appreciated its goals. It's a long time. It's not only engineering. Do we know how to manage a project that's intergenerational? Do we really know how to do that? We shouldn't think about it as a single project. It's not even a program or even a plan. All of those change. It's a function like that of a hospital. If we're going to do it, it's got to be a function. Human space exploration is something advanced societies do, period. You've got to think of it more like that. And then it becomes easier then to take care of the things that will inevitably happen. Disruptions in funding. We've already seen that with the space station and failures of the shuttle. And believe me, our partners have had changes of policy and funding in their economic outlook. So then, in addition, you have to change your philosophy of engineering design. You have to design for resilience. There are things that could happen that you didn't anticipate. Just as important, while you're going, you have to provide value and interest as you are doing it. It's not enough to have the final goal inspiring. Getting there has to be interesting. And so for that, there's all sorts of factors that committee will think about, the geopolitical, technical, commercial, education. But I believe eventually, at the end of the day, we will agree, despite the fact that science prospers better on robotic spacecraft, that for this project, the human witness and drama will continue to be essential. And then finally, you have to sustain a whole variety of supporting institutions, not only the NASA centers, but institutions in the larger social surround, in medicine and elsewhere, that will maintain a continuing interest in, and because they're following these enduring questions. So that's the question. Can the social commitment endure for the century? That is the biggest problem in a very long-term program. The challenges go way beyond engineering. I've talked about multi-generation. It's also important never to underestimate or minimize the difficulties. There has been an attitude out there, a NASA attitude, can do. Let's not talk about the difficulties. We can get there, we can do this, trust us. But on a 50 or 100-year program, it's the difficulties that you're overcoming on the way that provide the interest and presumably the advancement for society through technical and other evolution. Biomedical hazards are very large. Nobody knows exactly how to support life for 50 years. Or telemedicine, how are we going to do that? Well, that's going to already is spurring advances in robotic surgery. Now, here's another one. Once you leave low Earth orbit and you're not shielded, which is very expensive, you can remain in space for 270 days. And at the end of that time, you will have received the maximum lifetime radiation dose of a radiation worker. Okay? Now, that doesn't mean you're going to die right away, but it means that as far as the government is concerned, you have quite an unacceptable risk of cancer in later life. And so it's very hard to see governments willing to assign this kind of risk to astronauts, but it's somewhat easier to see the commercial enterprise taking on this risk, or at least facilitating those who want to take it on. And then finally, once again, social commitment has to endure for a long time. So it has to go from President Kennedy to Obama to some unknown future president 50 years from now. So here's what I think is the bottom line, and the one that I will take to China next week. In my view, only the globe can take the world where it wants to go in space. Only the globe. So the human relationships that stem out of shared common goals to answer those enduring questions, that is the biggest and most difficult social engineering problem of the world. If we don't get there, it's very easy to say, the fault will not lie in our stars, but in ourselves. So thank you very much. You've been a very good audience. I promised Howard here the first question, and then after that we'll go there, and then somebody over here, and that'll do it.
Repeat the question.
Yes, and I'll repeat the question. He never knew what the space station does, and he never knew about the costs of taking it someplace else. So what do they really do up there? At the present time, I think the most important experiment on board potentially is, in fact, the alpha magnetic spectrometer. But there are dozens of experiments on board that have been placed by our partners, the Soviet, the Japanese, and the European Space Agency, mostly small experiments carrying out the failed ambition of those experiments that did not work on the space station, but can work here. In addition, NASA itself, the science divisions of NASA themselves, who were very resistant to working on space station. First of all, because it was subject to so many policy fluctuations. Anytime you got involved with the space station, you had the chance that your budget would be ripped off to fund something else, as has happened. The scientists were very leery of getting on the station, but now that they can see that there's a commitment to indefinite operation, now you're going to see various experiments, particularly for Earth science. Routine observations of solar luminosity will just the little fluctuations in sunlight actually make a difference on the climate. And so they're doing that, and they're going to be putting some astronomical instruments on board. The station isn't the cleanest environment in the entire world for high precision optical measurements, but now you're finding that the science divisions are coming on board. There's a whole collection of experiments that the Europeans are doing in particular, but the important thing about zero gravity is there's no vector in space, there's no preferred direction. And it turns out that many biological molecules have an axis of symmetry. They have a direction to them. And so when they interact on Earth, they all get, if you let them go for long enough, they'll all get aligned by gravity, but up in space they'll be randomly oriented. And it turns out that you get different reaction rates in space, and there is the possibility then of some new discoveries. But you cannot expect that the first experiment that you do on something like that is going to provide pharmaceuticals into the indefinite future, which is the way the space station had been sold. But if you treat it as a continuing commitment to a scientific program, then I'm fairly certain that we'll get some science out of it. Was it worth the $70 billion? Probably not. But we will retrieve, but from the moment on, the goal is not the sunk cost, but to make sure that it earns its way into the indefinite future, and that's a different calculation.
Maybe one more question.
Yeah, one more over here, yeah. The question is, with the emergence of China, how do I think that will play out for the International Space Program? I think the answer is, eventually, I think it will be very important in an intergenerational sense. However, don't expect anything to happen in the short term. There is a congressman from Virginia who, with some justice, is highly disturbed by the Chinese incursions on our industrial programs, and is disturbed about cyber snooping and the like. And so he's succeeded in getting a bill passed that forbids NASA from having bilateral discussions of any kind with the Chinese. That the academies can do it, but the government cannot. So there will be, it'll be a while before, if we do that at all, the resolution of that problem is well beyond NASA's scope and is in the level of extremely high international politics. Now, the other thing that's interesting is that when we were on the Augustine Commission, we actually asked one of the questions that came up was, isn't it the case that the Chinese are going to beat us to the moon? And aren't they going to win the second competition to the moon? And this had some people quite anxious. What the Chinese said, I think, does characterize their program. They said, we're not competing. It's not a competition. We'll get there when we're ready. What we're interested in is building up the capability of doing it for ourselves. We're interested in developing our own programs. We're not competing with the United States. That's what they said. And this was a way of neutralizing and neutralizing our attitudes about it, and preventing what could have been a wasteful race to get there first. It's expensive to try to be first, and it's much wiser, I think, to take the long view. And so that, I think, was wise. But my understanding is that that still characterizes their program in space. So I think over the long term, mutual cooperative space exploration won't happen until both sides, till they both accept the same enduring questions on the basic human side, and both sides see that there's some advantage to collaboration.
Charlie, thank you again. We'll take more questions afterwards. Thank you very much.